In this video, we're going to continue with materials in Unreal 4. Now what I'm going to talk about is material inputs. I'm going to break up this section into several videos just because there is a lot of stuff to cover when it comes to material inputs. So if I go back to my material, you can see I've got a lot of inputs here. And these inputs are base color, metallic, specular, roughness, emissive color. And you notice that some of these inputs are available to use, so they're white. Some of the inputs are grayed out and they're not available to use. And this changes based on the type of material you have. And the way this works is pretty simple. I'm going to create a 3 vector by holding 3 and clicking on the graph. I'm just going to change the color here real quick and just realize it's not going to change color if it's still set to black. So I'll double click it, change this to a reddish sort of color. And now you're going to notice that our shader appears to be sort of this pink red color, and that's the base color. Base color is pretty simple. It just defines the overall color of something. So if a ball is going to be red, the base color is going to determine if it's red or not. The metallic is a setting that lets you control if objects are metals or not. So I have a metallic node here, which is actually a 1 vector, and if I plug that into the metallic, you notice that the shader, we look at it over here, appears to be more metallic in nature. So before it had just this plain sort of diffuse red color on it, now it looks very metal-like. Okay? And there's ways that we can control the metal. Now we have a specular and a roughness. Let me just jump to the roughness here real quick for a moment. I'm going to go to the roughness, and if I jump in here, right now the roughness is set to 0. And that gives us a perfectly polished glass-like surface. With the metallic setting set to 1 and the roughness set to 0, we get a perfectly polished metal. So it looks like a metallic marble that's perfectly clean. If I go into the roughness parameter and I change that, say, to something like 0.5, it's still going to look metallic, but it's going to look a lot rougher. So if I look at the surface, it looks more like a brush sort of metal. It's a little bit more matte. It's not as shiny as before. You can still tell it's metal though. And if I reduce that a little bit, you can see that it starts to go more to a polished state. So roughness controls how polished or unpolished a shiny surface looks. Now we have emissive color, and emissive color is really important. Emissive color is used for anything that needs to basically glow or self-illuminate. Alright? So let me show you an example here. I'm going to take this checkerboard texture and plug it into the emissive color, and you're going to notice that not much is going to happen. Basically, if I jump back to the viewport, the white checkerboards remain the same, but the black ones are now red. And that's because our base color is currently red. So let me drop the color here, and it's going to look almost black. Almost like it's a black metallic surface with kind of a red reflective property to it. Okay? And basically, what the emissive does is it's going to make this thing self-illuminate. So in order to demonstrate that, I need a much better example, which I'm going to do right now. I'm going to create a multiply node. I'm going to create a 1 vector, which is just a number. Now let me actually select the texture sample. I'm going to plug it into the multiply. And let's create a constant 3 vector instead. And this is going to give us a color with RGB. So we can change the color of the emissive as we see fit. So I'm going to pick, say, like a blue color. I'm going to increase the value there and the saturation. So I'm going to make it very, very blue. I'm going to plug the results of the multiply with the emissive color. Basically what I'm doing is I'm taking the texture and I'm multiplying it by blue and then plugging that into the emissive. And that makes the blue area here, which is represented by the white checkers, to look like they're glowing. So to get these things to really pop, I'm going to take the value parameter of the blue and I'm going to crank it up to something like 20. And that's going to make this thing really glow. You can see now it's completely self-illuminating and glowing. It almost looks like some kind of irradiated sphere. And if we look at it in the viewport, that really starts to look like it's glowing, like it's self-illuminating itself. Maybe it's just full of some kind of weird photon energy inside. So I'm going to crank the value of the blue to 60, apply the changes. Let's have a look at it. And now it's really starting to glow. The darker areas, or the darker checkerboard patterns, those guys are being almost look blue now, because the blue from the glowing areas is so strong that that glare is starting to really take over the image that we're looking at. So emissive color is pretty cool. Use it for anything that has to glow. Say you've got a futuristic body armor plate on a crazy looking sci-fi space marine guy, and he needs little lights on his helmet or his shield or his armor. You want to use emissive to be able to make those things pop and glow and all that stuff. So I'm going to undo all this stuff. I'm going to plug my checkerboard texture back into the base color, jump back into the viewport, and you'll see that after I apply the changes, we're back to just a regular checkerboard object here. Okay, so let's talk about specular a little bit. Now, normally you shouldn't mess with the specular. By default, specular is about 0.5 in the material. But if you want to, you have the option of adjusting that if you want to have more artistic control over the shininess of your object. So here I have a specular node set to 0.5. I'm going to plug it into the specular slot, and I'm going to change the value to 0, and let's see what we have. You can see, just keep in mind the specularity of the object, which is shininess. I'm going to go ahead and increase that to 1. And if I jump back, or I got to apply the changes first, you can see the object, especially around the edges, is a little bit shinier and brighter. Kind of hard to tell. You might have to crank up the setting really high to see a huge difference. But the specularity parameter allows you to overdrive and push the specular component of the shading model a little bit further. Normally, you shouldn't really have to mess with the specular, but it's there for you in case you want to have more artistic control. Okay, then we have normal, and normal map is pretty straightforward. Let me take out the base color, and now if we look at this, I need to come over here. I need to give this some kind of a base color. So I'm going to go ahead and create a 3 vector and go with like a pink sort of color again, just because it's easy to see. I'm going to hook that up to the base color, and we can go ahead and apply the changes and have a look at this. So we're back to having basically a metallic sort of shiny marble looking object. And now what I'm going to do is I'm going to take the normal. I'm going to take a normal map, which looks like this. It's a checkerboard normal. And I'm going to plug that into the normal slot of the material. I'm going to apply the changes, jump back into the viewport, and now we can see that we have that checkerboard pattern as a normal map on our object. And if you've never heard of normal maps before, that's kind of outside the scope of this video. So if you want to know more about normal maps, there's lots and lots of information on the internet about them. They've been around for years, for the better part of the last decade, and they're used in game development to make simple objects look more complex by faking detail with the use of one of these bluish normal maps. So I'm going to plug my texture back into the base color, just so that we're back to where we were before, and we can see the changes a little bit easier. Okay, so there's still a lot more nodes and inputs for this material that we can adjust and change, and I'm just going to set this back to how it looked before when we first started. Okay, that looks pretty good. So next we're going to talk about the world position offset, but this video has gone long enough, so I'm going to end it here. In the next video we'll continue talking about more of these Unreal inputs.